Greetings. Welcome to another video where I will show you how to use the solution map for logic. So here in logic, usually they come in a table form or the word propositions. So here we have the propositions that have been transformed into symbols. So for example, I cleaned the house. That proposition is represented by A, and mom is happy. That proposition is represented by B. And so now our job is to determine when is the proposition when are the propositions true when they are combined together. So first we arrange the proposition such that, okay, in A we have true true false false, and then for B we have true false true false, and then now here the T is for true and the F is for false. You can just look through this table and try to understand what's going on. So for instance, let's just go through the last here. It says if B is true, A should be true. If A is true, B should be true. The same applies for false, which means the same applies for false. That is, if B is false, then A should be false in order for this statement to be true. So for instance, we have this statement reads A implies B and B implies A. Usually the way most people read it is just A if and only if B. So let's see here. So we know that this here it's A if and only if B. That means if A is true, B also has to be true. So because A is true and B is true, so the statement A implies the statement of A if and only if B, that statement is true. And then we have A is true and B is false. So this statement is already false because A is true, B is false. In order for this statement to be true, B also has to be true, or A also has to be false. So that's false. So the same applies here. A is false, B is false. The whole statement becomes false. But then now when A is false and B is false, the statement is true. So just if you read through the table, you will understand more with the other propositions. So now we have like how we can negate propositions. We can rearrange them and form different types of proposition. So first we're going to look at negation. So to negate a proposition, you put this sign here, and with this, put this sign, then you put the symbol that represents that proposition, which is going to read as not A. So the negation for A is not A, and that is represented by this. This is how you write it. And then we have the converse of a proposition. When writing the converse of a proposition, you basically switch the hypothesis and conclusion. For instance, if you have A implies B, to write the converse of this proposition here, it just becomes B implies A. And then we have the inverse. So inverse means you take both the negation of the hypothesis and the conclusion, as shown here. And then we have the contrapositive. Here we swap or switch the hypothesis and conclusion of the inverse statement, as shown here. So next I'm going to solve questions using this solution map. Thank you for watching.